Okay, so now that we've got our leg in place with both its stretchy IK, the manual ability to stretch the upper leg and lower leg, the ability to lock that stretchiness and the twist control, let's turn our attention to the foot setup. Now if we jump over to the whiteboard, if you recall, with our foot we wanted to have our lower leg bone come down something like so, then we've got our foot bone, then we've got our toes bone, and we wanted to have a control that sits around our foot with a pivot point just underneath our ankle, and we wanted to be able to move and rotate the entire foot based on that. But we also wanted to have two rotational controls, one that sat around the ball of the foot and one that sat around the very tip end of the toes of the foot, so that we could either rotate up the foot bone with the ankle rotating up in an arc, something like so, or we could rotate up the entire foot about the toes with both the toes, then the foot bone, and then of course the ankle rotating as well. So how are we going to approach something like that? Well, let's take a look at what would happen if we had a single bone IK chain. If we had a single bone in a chain, we had our bone, and it was set as the only bone in that IK chain. That means that bone is going to aim along its length and always aim at that IK handle. If we were to move the end point of that bone, that means that as we move the end point, the bone is going to aim down at the IK handle. If we were to rotate the bone about the same point as our IK handle, that means that we're going to move, but we're going to maintain that same distance from the IK handle, so we'd aim at the IK handle and indeed still sit touching the IK handle. So what if we were to apply single bone IK, so basically IK with a single bone in that chain, to both our foot bone and our toe bone? That gives us something that we could start rotating the bones, and we get something like our roll controls set up. So what we can do, we can add IK to both of those bones, and then we can go ahead and we can set the IK handles to be those control objects that we wanted for rotation. So let's take a look at what that would look like. Let's just say, for example, that we start off with just the foot bone. So we've got our lower leg coming down, then we've got our foot bone. I know this is way out of scale, but it will work perfectly for what we need. So we have an IK handle for our leg. If we were to come in and create IK for our foot bone, but then make that IK control our rotation control, what we can do, if we were to parent that IK handle up underneath that control, if we were to rotate that control, that IK handle is going to move in an arc about that control, moving our ankle up to a new position. So our lower leg would now stick out something like so. If this was our upper leg before, maybe it would look something like so in order to accommodate that motion. And then we're going to find that that bone rotates up and still aims down because of the IK that's now driving that bone at our roll control. In the same way, let's draw out, so we've got our leg, and then we've got our foot and our toes. If we were to have, there's our toe, ball roll control, there's our IK. If we were to have a toe roll control and parent our ball roll control up underneath it, if we rotate our toe roll control, our ball roll control is going to arc up somewhere like that. That means that that's going to cause our IK handle also, since it's parented underneath the ball control, to move up to here. So that means that our leg will move something like so. Then our foot bone will point down at the ball roll control. Then our toes bone will point down at the toe rolls control. You can see we've rotated our foot up. Now more accurately, this would be actually over to the side slightly, something like so, to maintain that angle difference there. But you can see that we've rotated the entire foot up about that end point. If we then came in and created a control object, our foot control, and had it as a parent of the toe roll control, that means if we move this control, we're going to move this control, and that's going to move the ball roll control, which will move the IK handle. Thus, if we move our foot control, the entire foot rig will come along for the ride. If we rotate that control based about its pivot point, the entire foot rig will rotate about that pivot point, and that means the entire foot will move. And if we move it will move the IK handle driving the leg as well. So what we're going to see in the network is something a little bit like this. We're going to have our foot control being the highest level, being the master parent, if you will. From there, we're going to have our toe roll control, which will be a parent of the ball roll control, which finally will be a parent of that original leg IK handle. And of course, the leg IK handle now isn't animator driven. This will actually be hidden and not selectable. Instead, we're going to drive it through the use of the foot control, ball roll, and toe roll controls, and that indirectly will drive the position of our ankle of that IK handle. Now, we also need to be careful with twisting on those bones. We'll see this more easily when we're over in Houdini actually getting this set up. But what we need to be careful of is as we rotate a bone based on a particular location. So let's say that this was our foot and this is our toes. And let's say we were rotating our foot bone around this point. So as that starts rotating, I want to make sure that the bone always points in the same direction and doesn't hit a point where it suddenly flips around and now aims in the other direction. To do that, what we can do, we can take that control object, that rotational control, we can make a null, a child of that control. Then our bone, if it's set to point to aim as an aim effector to that particular null, as a twist effector to aim at that null, that means as that null comes around when we rotate, our bone will always maintain that same aiming and will never twist and flip around as we're rotating our controls. Again, this will be a lot easier to see the problems once we're over in Houdini in the next video, and we can easily set up a twist effector that comes along for the ride with our rotational controls, and that will prevent any nastiness with the bones spinning around, twisting and flipping out. So with that, that's a look at how we're going to set up the foot control system. In the next video, we'll actually get this implemented. Thanks a lot.